Hello and welcome to tutorial 3 of the Platemaker Wizard. So we begin by opening Excel. In order to do tutorial 3 you must have an activated version of the Platemaker Wizard. Activating the wizard was described in tutorial 2. So first of all we are going to open up our instruction manual, which contains all our tutorials, and I'm going to go down to the beginning of tutorial 3 and we can now follow tutorial 3. We don't need to put the Platemaker Wizard into tutorial mode because this is the first time we're going to build a container workbook without the help of templates. So let's jump in and begin. So the first thing that we're going to do is we'll close this one, and we shall now go up and go create new data entry workbook. We are going to completely skip page 1. So the great thing about the Platemaker Wizard is everything on page 1 is optional. You don't need to fill it in to build workbooks. Obviously, if you don't put any information on page 1, there won't be much information in your experimental details tab of the workbook you build, and also you can't save the file if you don't have any information on page 1. But that's fine. For this tutorial we're just playing anyway, so we'll simply click next. And this is page 2 of the wizard, which is the page we're going to be learning about today. So following on the instructions, so if you've got your crib sheet in front of you, the first thing it's telling us to do is we're going to do a simple experiment of testing a series of compounds at different doses. So a very nice simple experiment to begin learning how to use the wizard. So the first independent variable I want to put in is compound, and the second independent variable I want to put in is dose. And you can see that because I've entered these before, this drop-down list has remembered the different things I've entered before. This is a standard feature of the Platemaker Wizard. So compound and dose are our two independent variables, and we've already talked about the fact that when we create the workbook, what it is going to do is in the flat data table there will be one column for compound and one column for dose. So this is corresponding to the future columns that are going to be created in the flat data table. You can also see that the link is combinatorial, and we'll talk about what this linking means in a moment. So following on our instructions, the first thing we want to do is compound is going to be a text variable. So we'll click text variable. And we're now going to enter the text. So at this point you may be typing in the name of drugs. For now, I'm just going to simply type CMP space. This is what you're told to do. And then we're going to use this handy independent value generator to just create some fake data for us. So we'll make the starting value 1, we'll increment by 1, and we want 10 data points. We push the return key, and now we have 10 compounds entered into our first compound box. We now move our cursor down to dose. This is now empty. You see it's defaulting at nanomolars. We'll assume that we want nanomolar doses. We'll assume we want a semi-log dose response curve, and we shall start with our top dose of 1000. We want 5 data points, so we put 5 in here. You can see the bottom dose, it's already calculated as 10, so we push return, and we now have our semi-log from the independent value generator. If instead of typing 5, I just typed 10, in fact we can do that, so let me just delete this. If I just type the end value as 10, it automatically works out that there's 5 points. So you can enter any of this information and it completes the other boxes for you. So we now have our compound and we have our dose. So the next thing we will do is we'll flick over to the next page. So this is our dependent variable page. So this is the measured variables that are coming back from any microtitre reading machine. And the two variables that we want to measure are cell count. So I'm going to type in cell count. We have an option of putting dimension in here. I really strongly recommend you always put dimensions with any of your measured variables. So for cell count, this would just be number. So I'll push add, and then the other one we want is cell depth, and for that it's definitely percentage. So I select percentage and click add. and that's all we're going to do on this page. We'll also look at plate controls in future tutorials, but not today. I then push next, and this is our equation editor. So this is, remember, in tutorial 2 we looked at how we can take our dependent variables and combine them into equations to get new derived values. We're not going to do that today, but we'll be learning about that in a future tutorial. And finally we come to page 5 of the wizard, and this controls how the samples that are being generated from page 2, the independent variables, will then be laid out on the plate. So what we're going to do is we're not going to change anything here. We're just going to click the preview button and see what it does. So let's just click the preview button. And when we do this, you will see it creates this workbook with the following plate maps. So if I go back to the crib sheet, we have pretty much done all of this. So we've worked through all of this. And we'll work down. We've gone through this. So we're now here. You can see this is the plate map in our crib sheet, which matches the plate map here. So you can see we have compounds and we have dose. If we go to the flat data table, you can see that the compounds are first and they are all grouped together, compound 1, and these are the dose. So the combinatorial link, what it's done is it's taken compound 1, created compound 1 1000, compound 1 316, compound 1 100, compound 1 32, compound 1 10, and then it's done the same with compound 2. So effectively what it's done is we had 10 compounds, 5 doses. 10 times 5 is 50. It's created 50 different samples using those combinations, with compound grouped and then dose changing row by row in the flat data table, and compound grouped together as shown. So what we're going to do now is we're going to click reject, and we're going to explore what happens if we change the layout direction from by rows to by columns. So let's just do that. Click preview, and when we do this, you'll see it's now built it by columns, and quite obviously you can see that if you're following instructions, this is very easy. By rows is going literally the samples just laid out flowing in rows. Now they're laid out flowing in columns, but it's the exact same samples. So we're going to click reject again. We're going to put it back to by rows, and this time we're going to exclude the outer columns, which will make the plate map look a lot cleaner. The exclude outer columns feature is here because often in high content screening experiments, especially with 384 well plates, the edge wells are not very accurate because you get more evaporation in the edge wells than you do in the center wells. So if you have drugs or experimental samples in the edge wells, often the concentration of the compound is not correct. So a standard practice in high content screening experiments is to exclude the outer columns and the outer rows to avoid these edge effects. So for now, I'm just going to exclude the outer columns and push preview. And you see when I do that, it looks a lot neater now because it fits nicely onto the 96 well plate. So we will now return to our crib sheet, and when we do this, the next part of the exercise is to swap the order on page 2 from compound dose to dose compound. So let's do that. So we go to here, we click the reject button, we go back to column names values or page 2 of the Platemaker wizard. At the moment we have compound and dose. What we're going to do is select dose and push the up arrow so that now we have dose and compound. We click next, we click preview, and when we do that, you will see it has now produced a different plate map layout. Now the compounds on the right plate, the dose is now grouped in rows and the compounds are changing across the rows. You'll also see that on the flat data table. So in the flat data table before we had compound here and dose. Now we have dose and compound, and now you'll see the doses are grouped as we move from row to row, and the compound is changing as we move from row to row. In the previous build, it was the dose changing as we move from row to row and the compounds grouped together. You can compare this directly by looking at figure 59. In the crib sheet, there's the original build. You can see the compounds are grouped, so we have compound 1, compound 2 in row, compound 3, compound 4, doses changing in row. But in this build, we have the doses to the left, and these are now grouped, so we have all of the dose 1000 with compounds 1 to 10, all of the dose 316 with compounds 1 to 10, and so on and so forth. So the linking order can become very important in terms of controlling exactly how you want the plate to be laid out. In this example, you could lay it out either way. Each plate design is experimentally tractable, but in some cases, changing the linking order has quite a dramatic effect, where one particular linking order would be impossible to lay out on a plate, but the other one is completely doable in terms of physically executing the experiment. This is also explained in your crib sheet on figure 60. So figure 60 really explains how the linking orders work. So here you can see our diagram. In the first link where compound is to the left, in the flat data table or in the top of the list box, we have compound grouped and then doses. And if we swap it around, we then have doses, as you see, all grouped together, and compounds. So hopefully this will give you a clear explanation of what is happening. The way I like to think about it is the columns further to the right are a bit like the units when you're counting. So the units obviously turn over first, and then once they've completed, you then increment the next column, which would be the tens column, and so on and so forth. That's another good way to think about it. We're now going to move on to the linear link. So let's do that. So what we're going to do is we're going to reject this build. We're going to go back to the column names value page. We're going to put it back to columns by dose, but now we're going to change the combinatorial link to a linear link, like so. We're then going to click next. We're going to run the program again, and this time you'll see we only have 10 samples rather than 50 samples. And the reason we only have 10 is because the linear link works differently from the combinatorial link, and this is also explained here. But if we just quickly look at the flat data table, how it works is it literally is just combining whatever was in the text box. So if you remember, in the text box we had compound 1, 1000. In fact, let's just do this. Let me just reject it so you can see this. If I go to column, you can see that we have compound 1 and then we have dose 1000. So literally it takes compound 1, dose 1000, compound 2, dose 316, compound 3, dose 100, and so on and so forth. It's literally just doing that, and this is why we end up with only 10 samples, because effectively what it is doing is it's gone compound 1, 1000, it gets all the way through the first 5 doses, and then compound 6, it's now run out of doses, so it just simply cycles them again. So it got through the first 5 compounds for the first 5 doses. Compound 6, it has to repeat itself, so it's done that again. And then the same with cell death, so it started compound 1, first 5, 10, and then compound 6, it repeats again. So that's how it deals with a linear link. So we'll now reject this. We shall go back to our column names values page, and we're now going to put it back to combinatorial link. And you might be wondering, well, why is linear linking useful? And the reason it becomes useful is because it allows you to define unique dose compound values or unique sample values. So in other words, the drawback of the combinatorial link, of course, is that it's a repeating pattern. But let's imagine, as can be quite common in a dose response drug experiment, you might have some drugs that are intrinsically more potent than other drugs, so you want to use them at different doses. The linear link allows you to make those sort of adjustments. You might have a drug with unique doses. You can record that using linear linking. And that is what I'm going to show you now, how we do this. So what we've done is we've changed it back to combinatorial linking. What we're going to do now is we put our cursor on compound and we're going to select this pause build. So it says pause build. We're now going to go next and we're going to go preview. And this time what will happen is you can see that the program has paused its build before it's actually built the flat data table completely. It's paused it at the point where it's just combined the compounds with the doses. So we're now going to follow the instructions in our crib sheet, and you can see this is where we're at now. And what it's telling us to do is it wants us to change compound 3 and 7 to give this unique doses here. So let's do that. So we can use the filters to do that. So we're going to click on here and we're going to select compounds 3 and compound 7. And then we're going to replace the numbers, the standard numbers of our dose response with these numbers. So let's do that. So it's 5,000 and it's just this time it's a log dose, 500. 50, 5, and then 0, 0, 5, 50, 500, and 5,000. Okay, so we're just following our instructions, and then we're simply going to push finish editing. And now you see when we've done this, we now have unique, these two, this is compound, you can see if you look at the map here, this is compound 3 and this red one is compound 7, and you can see that we now have these unique doses. So we've managed to capture these unique doses inside our plate maps, and the same thing will apply to our flat data table. So there's compound 3, you can see it goes into a different dose range. Now if I reject the build and I go back to my column names values, you will see that the data is still in combinatorial. It hasn't actually been saved. So if I was to run it again, I would just end up with the original data build. And in fact, I can do that. So let's do that. I'll run it again. I'm going to leave it on pause build. And you can see I get the same flat data table I had before. So if I said finish editing, I haven't saved. It hasn't saved the changes that I've made. This time I am going to save the changes, so let me show you how I do that. So let's do the exercise again. So I'm going to select compound 3 and compound 7, and I'm going to enter my, remember it's 5,000, 500, 50, 5, 0, and 0, and 5, and 50, and 500, and 5,000, but this time I'm going to tick Save Changes to Wizard menu. I click Finish Editing, and now you can see it returns me to page 2. And look at this, I now have linear links because you can see this is how it's managed to record the information. It's actually now saved the unique doses that I need for my compound 3 and 7. You'll also notice it has taken off the pause build because it no longer needs to pause the build anymore. If we use this particular information, we'll always get the required plate build we need because it has now been saved in a flat linear link on page 2 of the wizard. So the next thing we want to do is we're going to reject this, and we're now going to expand our experiment by adding two other independent variables, duration and cell line. So let's do that. So we're going to reject this build. We're going to go back to column names values on page 2, and we're now going to add two new variables. We're going to enter duration, and we're also going to enter cell line. Now you can see they have entered below these. We want these to be combinatorial because we're going to have them in the presence of dose and compound, so we change these to combinatorial. And now if we're thinking about linking, we obviously want to have both duration and cell line grouped together, because when you execute an experiment, often the time course, you want the times grouped, ideally on the same plate. And also often you want a cell line on an individual plate because it's a pain to have multiple cell lines on the same plate. It's easier just to plate a cell line on a single plate, so you have different plates for different cell lines. So remember, in terms of our grouping variables, we want cell line therefore most grouped, so it needs to go to the very top of the table. And we also want duration grouped as well, above compound, but probably below cell line. So let's just move it up here. So it's now we've got our two new variables. And now we need to give some values to these. So if we go back to our tutorial, you can see that what it wants is it wants us to add PC9 healer and STC1. So let's do that. So for cell line, that becomes a text variable, and we want PC9, and then we have healer, and then we have STC1. So there are our three cell lines. And for duration, this needs to be a numerical variable. Duration is obviously a number, so we untick here. And the numbers we want to enter, so the dimension pops up, we need to put that as hours. And the hours are 24, 48, 72, and 96. Oh, notice we can use the add key, but also I can use the keyboard as well. So you can either click the add key or you can use the enter key as a shortcut. So we've entered the data here, so we have duration and we have cell line. You'll notice that the relationship here is still linear. These are linear, but this one above is now combinatorial, and this is also explained. You need to read this in your instructions here. So it explains how the order's working. So you can see it's duration, combinatorial by cell line, by compound, by dose. And there's also important to understand which link controls link. So it's the links between the different independent variables that are important. So when we look at this last link is irrelevant. This could either be linear or it can be combinatorial. It makes no difference because it doesn't mean anything. If I change this to combinatorial, it'll make no difference. The important link between compound and dose is this one, linear. So the last one is always ignored. In the same way, if you push pause build here, it's not that useful because it'll pause after building the first variable, which is just dose, which will just get back dose. So that's not much use either. So just to be aware, these last two don't really reflect anything practically when you're doing a workbook build. This is also explained in the tutorial here. Okay, so we're now going to go back to our last page of the wizard. We're going to click preview, and when we do this, you can see it's a much bigger experiment. We build the following. So we now go back to page 5 of the wizard, and before we build our next workbook, we are going to complete excluding not just outer columns but outer rows, just like we explained. Remember, we talked about this in terms of a normal procedure if you're doing high content screening experiments, but this will also clean up the plate maps for us. And we now push preview, and if you've done everything correctly, you should end up with these plate maps. So this should match. Again, if we go to our workbook, you can see this matches figure 70, and we have built our next plate design. So looking at this plate design, you can see that one issue here might be the fact that we have a 48-hour line inside our 24-hour line, which is not ideal. So it's obvious that we probably want to exclude this row to get the plates to work. So it's very easy to do that. So if we click reject, we can use subplating areas in order to exclude a row. So you can see at the moment, because we've excluded outer columns and outer rows, the number of columns is 10, the number of rows is 6. Let's now change that to 5. We don't want to use leftover space, so we untick that box. You can see it's now gone to 12 plates. We run it again, and when we do that, you will see that we end up with this figure here, which is now nicely laid out. So you can see we have 24 hours and the cell line PC9, 48 hours and the cell line PC9, and so on and so forth. And this would be a doable experiment on a 96 well plate. So this is the 96 well version of this particular experiment. So in the final exercise, if we go back to here, what we're going to do now is we're going to convert this experiment to a 384 well plate. So let's do that. So we click reject, and we're going to change this from a 96 well to a 384 well plate, which we've now done. And we push the preview button, and as soon as we do that, we will get the 384 version of this workbook, which we now have. And you can see it looks pretty hairy, pretty messy. So what we're going to do is we're going to start to sort it out. So just looking at the compound map, you can see that all the compounds would fit nicely if, rather than 22, the edges are still excluded, then rather 22 columns, we had it in 20 columns. So let's do that. So we'll reject that, and we'll put the subplating area back to 20. We need to exclude the leftover space. When we run it a second time, you will see that we now have this plate map. So we've fixed the problem of the misalignment of the compound. So you can see how, using the Platemaker wizard and the preview, you can design the plate layout on the fly. By looking at the maps, you can very quickly sort out exactly how to lay out the plate so that it makes sense. So this looks okay, except we have another issue, and that is, if you look at the duration, we now have 24 hours to here, and then suddenly we have it going to 48 hours. So ideally, you would probably want to separate this completely, but also you wouldn't want a change. You definitely wouldn't want to change halfway through the plate. So let's now add some space, so that rather than have the 24-hour stop at row 11, at least there's a space here before we start the 48 hours. So this will be the next exercise. So we're going to add some space in here. So let's do that next. So the way we're going to do that is we click reject, and then we're going to click go to, and we're going to go back to the column names value page. We're going to go down to the compound, and we know that the 10 compounds that we have, we need an extra compound. If we look at the map, I'll just show you on the map here, you can see here's the first 10 compounds. Okay, you can see them fitting across here. So if we could fit, so we've got here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we could fit another 2 compounds in here, then that would create that space just in there. Okay, you can see that each compound occupies 5. We need an extra 10 spaces. So we need to put, if we put 10 spaces in here, that will free up those 10 spaces there. So let's do that. So this Platemaker wizard provides a special character for adding space, and it is the hash character. So if I add the hash character, that would work. But remember, because this is a flat data table, I need to add it 10 times. And this is where I can use this clever function here. So what I'm going to do is I'm going to click single. I'm going to first of all click multiple, and then this extra box comes up. I'm going to enter the number 10 in my box, like so. And then I'm going to enter my hash character, and I simply click the add key. And now you can see it jumped to 60, and it's put 10 hash characters in here, which is there. Now I'm going to go back to my final page, and when I preview the build, lo and behold, we will get what is required. So now you can see that we've created this space, and now our 24, 48, 72 hours and 96 hours is nicely separated into separate rows. And again, if you're following in your crib sheet, if you've done it all correctly, you will now see this is this build here. So looking at this plate map, we've sort of fixed the time course problem if you're happy to have different time courses on the same plate. And by the way, you can do that, because remember, with an HCA experiment, the way you would do this is you would work backwards. So you'd put a drug, say, on here first, then 24 hours later put the next drug on, 24 hours later put the next drug on, and so on and so forth, and then fix it all at 96 hours. So you can build time courses into a plate like we've done here. But the problem here is what you wouldn't want is you probably wouldn't want changing to a cell line from PC9 to healer on the same plate. That'd be a real hassle. So what we need to do is we need to finally just have a space in here. And of course we can do this very easily. We don't need to use a spacing character. We can do that with subplating on page 5. So let's just do that. So we're going to reject this one last time. We're now going, so rather than have 14 rows, we need to change this to 12 rows as a subplate, and you can see it jumps to 3 plates. And if I push preview one final time, you can see that now we have our time course nicely separated into the different rows, and we also have our cell lines nicely separated onto different plates. And this really is the end of tutorial 3. So just to finish off, I will now just finally accept this because we finally have the plate maps that we want today. And if I accept it, you'll see that now the workbook is left on the screen. It hasn't been saved, remember, because we didn't ask it to be saved on page 1. And if we look through this, you can see we have the plate maps. There's our flat data table. There's the container worksheets that will receive the data from our plate reading machine with the text version of each sample. And finally, if we look at the experimental details page, you can see everything is missing here because we gave no information on page 1, although it does insert the date that the workbook was built. So if you don't enter an experiment date, it'll at least put a single date of when the experiment was physically built, what day when you actually physically built this workbook, which has gone into there. Okay, so that is the end of tutorial 3. I hope you enjoyed this tutorial. If you did and you're watching on YouTube, please do like this video, and also please consider subscribing to the channel as we work through the functions of the Platemaker wizard together. I wish you well with your experiments, and bye for now until tutorial 4.